Okay, we're recording. Greetings, Earth and Space Explorers. Welcome to a special presentation on hurricanes in New England as part of the Rockport Earth Day 2020 events that will continue through the rest of this year. Video recordings of these events are being archived on the Rockport Conservation Commission's website. This particular presentation will also be available on Doc Waller's Earth and Space Reports YouTube channel. I'm your host, Dr. Bill Waller, an astronomer, science educator, and communicator, coming to you on a beautiful fall day that has gotten a little bit foggy here in Rockport, Massachusetts. Today, we are fortunate to have one of Rockport's own, Dr. Sarah Damassa, who will talk on winds of change, hurricanes in New England. Dr. Damassa earned her bachelor's and master's degrees in geology from Stanford University and her doctoral degree in geology from UCLA, where she studied paleontology. She went on to work as an independent consultant for oil companies, as well as the Bedford Institute of Oceanography in Nova Scotia, where she researched fossil dinoflagellates from core samples of the Atlantic Ocean's deep sea sediments. And in case you're wondering what a dinoflagellate looks like, here you go. Okay. Sarah also taught courses in environmental earth science at Lexington High School and coached Lexington's National Ocean Sciences Bowl team that made it to national competitions for 5 years. Officially retired, she now makes Rockport her home, where she is active with the Rockport Conservation Commission. And so without further ado, a hearty welcome to you, Sarah.
Thank you so much. So I'm sharing my screen now, right?
Sure.
Yeah. Okay. All right.
Perfect.
Good. Okay, here we go. Thanks, Bill, so much for hosting this, and also to Mike for being the driver here. Just by way of full disclosure, I'm not an expert on hurricanes. I'm sort of a fan of hurricanes, but I subscribe to the mantra, cool, something happens, but we didn't get hurt. So here in New England, we're vulnerable, but not anywhere near what you might expect in some other places. The first image here is Hurricane Teddy, which came through a month ago today, and which was a near miss for us. It did make landfall in Nova Scotia, and we did see some effects. Okay, and I'm gonna need, I do need my, okay. I'm hoping this is review, but here is the structure of a hurricane. In the center, you see the eye here, where the winds are spiraling. Air is coming down, is sinking in the eye, and that's what makes the eye relatively clear. Outside the eye is the eye wall, where the winds are strongest and the rain is most intense. And then you see the structure of the storm itself is a series of rain bands moving out from the center, and the air is exiting at the top of the storm and comes around clockwise in the northern hemisphere, but would go in the opposite direction in the southern hemisphere. Overall, the storm is rotating in a counterclockwise direction in the northern hemisphere. All right, so some images of the eye. This is Katrina in the upper left picture here. You can see the plane wing just down in the corner here. And in the lower right, there's Dorian with the sun beaming through. There's the plane propeller right there. And the picture in the lower left is Hurricane Michael, taken in Florida a couple years ago. And this is from ground level, looking up at the clear blue sky in the eye as it passed over. So what you're looking at is viewed from space in the upper right. There's the eye, pretty clear. You can, if you were there, you could see down to the ocean surface. The eye wall is well structured, and the eye wall on either side. Okay. This is Hurricane Katrina approaching landfall back in 2005. And you can see the eye and the eye wall. And I'm going to move the image so that you can see, let's see, I better do this, over what are called overtopping clouds. These are rain bands, and where the thunderstorms, cumulonimbus clouds, are punching through the top of the storm. Oops. Okay. All right, so what do you need for a hurricane? You need warm ocean waters, at least 80 degrees Fahrenheit or 27 C, to a depth of about 100 feet. So you need a big pool of very warm water. An atmosphere that is potentially unstable with relatively moist air. Generally, at least 300 miles from the equator. There have been a couple of storms that formed closer to the equator than that. There was one storm even that crossed the equator, but that's a very rare occurrence. Typically, hurricanes start with some sort of disturbance. A tropical wave off the coast of Africa is a common initial location, initiating spot for hurricanes. And the last ingredient is something called low vertical wind shear between the surface and the upper troposphere. That's the lowermost layer of the atmosphere where weather occurs. And you need that to be low in terms of ripping apart. So wind shear will rip apart the storm. And if the wind shear is not present, then the storm has a better chance of forming and maintaining its configuration. So this was from July of this year. And you can see going across the Atlantic Ocean here, a dashed white line. That's the isotherm for 27.8 degrees C. And so south of that line, temperatures are above 27.8 degrees C. You can see that in the Gulf of Mexico and around Cuba and the Bahamas, it's even approaching in the 30s. And that's definitely warm enough for a hurricane. So we had no problem with that ingredient this summer. Hurricanes form in basins, Atlantic Basin, Eastern Pacific, Indian Ocean, Southern Indian Ocean as well, around Australia, and in the Western Pacific in the Northern Hemisphere. They tend not to form in the South Atlantic or in the Eastern South Pacific. West of Africa, west of South America, there are cold ocean currents flowing toward the equator. That sort of puts a lid on storm formation there, and conditions aren't so conducive along the coast of Brazil. I think there's been one hurricane that formed, I think back in 2004 in the South Atlantic, which made headlines, of course. This is a typical seasonal timeline for Atlantic season, showing hurricanes and tropical storms in red, total hurricanes in yellow, or only hurricanes in yellow. And you can see that the season for the North Atlantic peaks in September, which is about what we experienced this year. We're now approaching, we're about across the October 20th line, and you can see the season isn't quite over. Some storms have been known to form in December, not very many. And the last time we were in the Greek alphabet part of the hurricane season was at the very end of December. That was 2005. So part of the good news for New England is that we are not anywhere near as much at risk for landfalling hurricanes as, say, the Outer Banks of North Carolina, or of course the Florida Peninsula. The Gulf of Mexico is another sort of hot spot. We see a return, a period of maybe 13, 16 years, something like that. So we're sort of hanging out there in the Atlantic, but we're also quite a bit north, and storms can sort of wind down before they get to us. That doesn't mean we don't have any risk. Okay, just to look at a size comparison, this is pretty impressive. So my husband was saying that he thought the name TIP was confusing. It's not an evacuation plan. It is the actual name of the storm. This was a Northwest Pacific storm, which was enormous. And then here's tiny little Marco in 2008. Most hurricanes are in the few 100-mile diameter radius. And I think probably everybody is well familiar with hurricane hazards, storm surge and inland flooding, and wind damage, and of course tornadoes. So the pictures that I've shown here, the upper left is from Hurricane Laura, which was just earlier this summer. The one in the upper right is from Hurricane Harvey, which was 3 years ago now in Houston. both the wind damage and tornado pictures are from Hurricane Andrew in Florida, 1992. So you can see this is a piece of plywood that's been shoved right through a palm tree. So you can see why you do not want to be out in that wind. And this is sort of the classic place where you'd rather not live during a hurricane. This looks like a trailer park to me, and clearly structures with not very much integrity are at great risk for total damage and serious consequences. So one of the most destructive hazards of hurricanes is storm surge. And it's basically a dome of water that's pushed on shore by the winds. And if you add to that high tide, you can really get in big trouble. The diagram is a little bit complicated, but the thing to focus on is that if you are on the right-hand side or the eastern side of the storm, you're more likely to get very destructive storm surge because the forward motion of the storm is additive in terms of the wind direction. So you've got wind pushing the water onto the shore, adding to the forward motion of the storm. If you're on the opposite side of the storm, then the wind is pushing the water off the coast, and so you won't see the same kind of storm surge that you would in this case. Okay, I'm gonna get out of this and go. Brilliant, thank you, and hit share.
Bingo.
Okay.
Phew.
Woo! That was interesting. Okay, shall I start that over? It's not very long.
Mm-hmm.
Okay.
This better be good.
Well, I thought it was impressive, which is why I put it in. Okay, here we go.
Storm surge is often the deadliest part of a hurricane. Let me show you what that looks like, starting with a 1 to 3 foot water rise above normally dry ground. Now, this might not sound like much, but remember, this is flowing water being pushed by the wind. We know that 1 to 3 foot of storm surge can knock you off your feet, stall out cars, and even carry cars away. It is too late to evacuate when the water rises to this level. But let's go above that. Let's go 3 to 6 feet, for example. Very large objects can be carried in this kind of flowing water. They can act as battering rams and enhance the damage. But let's go even above that. 9 feet of storm surge. This kind of storm surge is not survivable unless you move to the higher floors of whatever structure you happen to be in. So please follow the advice of the local officials and evacuate as ordered when a hurricane moves in.
Can you hear me now still?
Not as well.
Not as well. Interesting. Okay. Hold on a minute. Is that better?
No, it's about the same.
Huh. Okay, I'm going to show second video and then we'll.
Okay.
Powerful winds aren't the only deadly force during a hurricane. The greatest threat to life actually comes from the water in the form of storm surge. Storm surge is water from the ocean that is pushed toward the shore by the force of the winds swirling around the hurricane. This advancing surge combines with the normal tides and can increase the water level by 30 feet or more. Storm surge combined with waves can cause extensive damage. It can severely erode beaches and coastal highways. The pounding waves can take out boats and buildings. As the waters move inland, rivers and lakes may be affected and add to the rising flood levels. While we can't prevent storm surge, we do have a system that can warn us of the incoming threat. As a hurricane develops over the open ocean, forecasters at the National Hurricane Center closely monitor its path to evaluate the risk of a coastal strike. They use a computer model called SLOSH to predict storm surge heights. The model depends critically on the hurricane's track, intensity, and size. SLOSH uses water depths, land elevations, and barriers to the flow of water to compute surges as they move inland. This data helps determine which areas may need to be evacuated. When a hurricane slams our coast, it's important to be aware of all the dangers. As a reminder, emergency managers want us to run from the water and hide from the wind. Don't take unnecessary risks during a storm. Conditions can change in the blink of an eye. Storm surge is a dangerous event during a hurricane, where furious winds are driving deadly flows of water from our seas to our shores.
Now, can you hear me?
Not as well.
Okay, what have I not?
Disable what you had.
Oh, okay. Let's see. New share, not new share. All right, hold on a second. I need to get back to the. So now it's on basic.
You're back to basic? Okay.
Back to basic, better?
It's a little better.
Okay. All right, I can. All right, we'll see how it goes. Wave your hands or something if you can't hear me enough, okay?
It will do.
Okay. This is the SLOSH webpage, which is kind of fun because it's got historical options. So you can look at different storms that had impressive storm surge. So this is the New England hurricane for 1938, and which of course is legendary. And if you just click the loop forward, you can watch the rising, the changing color, meaning the rising water as the storm moves across the area. So, and you can play with it a little bit. It's kind of fun. So I thought that was interesting. But this is the same program that's used to predict storm surges for hurricanes that are approaching our coast now. Okay, back to the slides. Okay, how's that?
Good.
Good, okay. So for New England, there are a number of famous hurricanes that have come across the decades, and these are just 4 of them. Each of them has a story to tell, and if you go to the NOAA Hurricane Center webpage and look at look for historically important storms, these are the sorts of things you find. And for each storm, there's a little story, a little summary that goes with it. So one of the things that was remarked upon for Carol and Edna in 1954 was that they were really back-to-back storms that had almost the same track. So they were both Category 3 storms. Carol made landfall in Long Island, over Long Island on August 31st, and Edna came over Cape Cod on September 11th. So they were really close in time, and it, you know, then those people must have felt like people in Bermuda do this summer when they've just been hit one after another. Donna, down in the lower right corner, shown here, the track shown here, produced 5 to 10 foot storm surges along the coast of New England. And the other one, the Great Atlantic Hurricane, also made a mess of things, but it was back in 1944. The next one, I think, is the storm that, well, maybe not a lot of us remember, but certainly is still talked about in New England. One thing that made this particular hurricane so dangerous is that the forward speed of the storm increased dramatically as it moved northward, so that it was going at about 60 to 70 miles an hour, which is really fast for a hurricane. So that people on the southern coast here had very little time. They didn't know what was coming. You know, it was a matter of hours between sunny morning and stormy conditions in the afternoon. And in 1938, of course, There was barely any weather forecasting, certainly no satellites, radar, any of the things that we take for granted today. So that storm made a mess of things. And the next slide shows an image of Long Island and the damage that was caused by that storm. That's just one image. Providence in Rhode Island was flooded really badly, and a lot of lives were lost. People didn't know it was coming. They couldn't get out of the way in time, so it was pretty grim. So there's the simulation for that storm, and which we just looked at a minute ago. And you can see that up at the higher end of the bay here, storm surge was on the order of orange, namely 10 to 12 feet. And also up here in Buzzards Bay, 10 to 12 feet of storm surge. Okay, so we're among the lucky ones in that we now have satellite imagery. This is an image from the space station from 2 years ago. And we also have Doppler radar, which not only tells us how the storm is moving, but where the rain is and all of that. So this is Hurricane Michael, which was quite severe a couple of years ago as it was about to make landfall in Florida. So that's our good news. I guess one way to think about it is the downside is that people now, more people than ever, live along the coastlines. And so just 10 years ago, almost 40% of our country's population lived close to the coastline. Those of us who live here obviously understand why that would be, but it also puts a lot more people at risk. And so it's important to be educated about hurricanes and what they can do. This year has been a record breaker. And you can see that if you compare this column of data formation with the one to the right, you can see that the last really active year was 2005. That was the year of Katrina, that was the year of Rita, and others beyond. That year also went into the Greek alphabet. But you can see that alphabet for alphabet letter, dates of formation were earlier for a lot of storms this year than they were in 2005. So it was predicted to be an active season, and that has indeed materialized. So in August, Hurricane Laura came to the Gulf Coast. This was a prediction for storm surge as it was happening. And you can see near the targeted area for landfall, storm surge expectation of 10 to 15 feet. And I guess Laura wasn't quite as bad as they anticipated, but it still was no joke, that's for sure. And so if you look at the next image, these are some images from Laura along the Gulf Coast there. And I thought those were impressive. Still not in New England. This was just a few weeks later. This was sort of the peak of our season this summer. At one point we had 2 tropical storms, 2 tropical depressions, a hurricane, and some suspicious looking masses of clouds and thunderstorms on the Atlantic Ocean, in the Atlantic Ocean at the same time. And this was today, September 14th. This is the same day. This is the satellite image. So here's Sally, Paulette, Rita, Teddy, Vicky, and that may have been the Wilfred storm that materialized as well. The next image was on the NASA Earth Observatory website for September 15th. This was at the peak of the California fires, and all of this brown and orange material is, or the coloring is black carbon. And the darker it is, the more dense the black carbon is. If you think back to the middle of September, we had a few days when our skies were obscure, they were pale because of the smoke coming over. And this image showed Sally and Paulette in place, and their presence was helping to steer the smoke that was coming across the country at that point. And then Teddy showed up. And this is Teddy again on the day that we had the big waves. and a bit of high tide, storm surgy sort of coastal activity going on. So the forecast in our area was for waves of 10 to 15 feet, and a lot of people were out there, Halibut Point and along the coast here, checking it out. I was one of them. So these are some pictures I took that day. This is Long Beach Road, and I was at the west end of the Cape Hedge parking lot looking to the west, and you can see an individual standing there near the edge of the water. This little black thing right there is the sewer manhole cover that looks like a mushroom when the water is not there. I think if you've been back there, you know what I'm talking about. And you can see the water level that's there. This was pretty much at high tide. This was in the afternoon on the 22nd. And the ramp over to Long Beach had been removed previously, but this is the water coming in. There's the footbridge. There's the ramp up there. And it was pretty impressive. There wasn't much Long Beach that day. Literally, when I walked around a little bit more to my left from where I'm standing to take this picture, the waves were up against the seawall that afternoon. And this was not a storm at our doorstep. This was a storm several hundred miles off the coast. It happened to occur at its closest approach at our high tide. This was the next morning. I happened to be walking down on Pebble Beach. This is near where I live. And I got there just as this scraper was arriving to clear off the rocks. And so I got out of his way and took a few pictures. All of this dark brown in the middle area here is seaweed washed over. And then, of course, the rocks. And it's now been cleared off. Ian, you drove through there today, I know. But anyway, that's a typical occurrence. And wherever you live in Rockport, if you're near the coast or you go there on a regular basis, you know the places where washover and flooding is likely to occur. Okay, I can pause here. Any questions at this point?
Was Superstorm Sandy a hurricane at any point?
It was a hurricane, and then it merged with a mid-latitude cyclone, which was coming in from the west. One of the amazing things about Sandy was that the models, the forecasting models from Europe, were predicting that it would take a turn to the west from out at sea before the American models were saying that. And that's exactly what happened. So it merged and became a superstorm. And by the time it was a superstorm, it was an extra tropical storm. So it sort of lost its hurricane tropical storm characteristics, merged with a mid-latitude cyclone, and became a superstorm. Does that answer the question?
Yep.
Yep, okay. So one of the things that, of course, is on a lot of people's minds, including my own, is wondering what can we expect as the planet continues to warm. The oceans, of course, are also continuing to warm. And I remember, I don't know, 15 years ago, that there weren't a lot of data to be able to point in a particular direction. Hurricanes historically have periods of more active years and then less active years, and it's not exactly decadal, but it seems to be on a longer scale than just year to year. So there was a lot of uncertainty early on about how climate change might impact the frequency, the intensity, et cetera, for hurricanes. Now the picture seems to be clarifying a bit. And if you go to any number of climate change websites, and my daughter-in-law, who is in climate communications, directed me to a couple where these websites and their contents are vetted by scientists that are working in the field. So I have a little bit more faith in them than you might have in some others. These are some things we might expect, right? Warmer water or warmer atmosphere holds more water vapor. That's just basic chemistry and physics. Another concern is that a weaker jet stream, that's the river of air that is flowing around the planet, between the troposphere and the stratosphere above that may lead to slower moving storms. And if a storm is moving more slowly, it has more opportunity to dump that rainfall that it is holding. Harvey and Sally this year, Harvey 3 years ago and Sally this year are good examples of that. Warmer oceans provide favorable conditions for hurricane formation. We already looked at one map that showed sea surface temperature. We're entering a La Nina year, and that has that El Nino La Nina oscillation has a component where La Nina produces vertical wind shear in the Atlantic basin, which then favors tropical cyclone formation. And then rapid intensification is a phrase that we're seeing more of or hearing more of. It seems to be an increasing risk as warming continues. The hurricane that's out there right now, Epsilon, underwent rapid intensification. Overnight, it became a Category 3 major hurricane. I think it's backed off a little bit now. When I checked a little while ago, I think the sustained winds were only 90 miles an hour. And it's not, it's going to pass a little bit east of Bermuda, but still, they're expecting tropical storm conditions tonight. Okay, so this is climate signals. This is one web page, and a quote from that page says, "Any planning that you might have made based on historical record is inadequate. It's a different world." And I think that's something to keep in mind for our town, for our state, for the country as we go forward in time. Just because it hasn't happened in the past doesn't mean it can't happen in the future. I now need to flip out of this to escape for a minute so I can show you these next couple of websites, but there's no video, so let me know if you can still hear me okay. Is that all right?
Mm-hmm.
Okay. So this is the Climate Signals webpage, and they focus on the hurricane season, and this is their website, and this is what they display as a way to sort of literally connect the dots for climate change as relates to hurricanes and so on. So if you expand all the dots for a minute, you see all of these consequences. Here's greenhouse emissions, global warming, and if you hover your mouse over one of these, you can sort of follow the track to see what's going on. So if you unexpand this and go over here to the Atlantic hurricane season, you can see that these are some risk factors that are happening and can be connected back to climate change. So this was sort of a fun website to explore, and they have a lot of interesting information here as well. Okay, back to screen. Okay, so just a saturation curve to re-emphasize the concept that warmer atmosphere holds more water vapor. That's why when it's the middle of winter and it's really cold here, it can be 100% relative humidity, and we're perfectly comfortable. And the opposite, of course, is true in the other direction. Okay, slower moving hurricanes. You can see a trend plotted on this graph that there's an increasing number of hurricanes that seem to be slow moving, and that has really major consequences for the amount of rainfall that can get dumped in any one place. Here's a map from Hurricane Harvey, and I remember at the time that the 40+ inches of rain were just staggering to everybody who was watching it. And Cedar Bayou, 51 inches of rain. So 5-day total, pretty impressive and pretty miserable for the people there. Okay, warmer water is going to equal stronger hurricanes, and here's Dorian as an example. This was last year. Dorian was the one that hit Bermuda as Category 5 and did tremendous damage. Okay, these are, can you guys see these okay? These are a little bit smaller. El Nino, La Nina is an interesting Pacific Ocean-based phenomenon that has global effects downstream, as it were. So El Nino has been recognized for a long time, especially by originally by fishermen along the coast of Western South America, Peru and Chile. And El Nino is a situation where the Eastern Pacific is warmer than usual. That puts a cap on upwelling of cold water, nutrient-rich water off the coast. And that leads to a drop in populations of plankton and fish and so on. So the fishermen noticed that. Studies in subsequent years have also identified La Nina, in which the colder ocean has a stronger upwelling, trade winds shift their speed, rainfall patterns shift, and from where we sit, we end up with more hurricanes in the Atlantic Basin in a La Nina year. El Nino is the one that Californians are really wishing for because that tends to bring more rainfall to California, but they're not going to get that this year. So see what happens there. Okay, rapid intensification is defined on this website as wind speeds of at least increasing by 35 miles an hour in 24 hours. And it's projected to happen more in a warming world, as I just mentioned. Epsilon has experienced that. Laura experienced that. And so we got to watch out for those. Okay, and this is another example still, Hurricane Maria, which pounded Puerto Rico 3 years ago, went from Category 1 to Category 5 in 24 hours. And you can see in the left-hand image, just one day, no eye here in Category 1, and a nice forming eye as a Category 5 storm. Puerto Rico is still recovering from this storm. Okay, another website that's fun to play with is NOAA's sea level rise website. And you can use that, it's interactive and I'll show it to you in a minute. You can use that to simulate storm surge and see what it would look like. And it starts with a map of the United States. And when you zoom in on Rockport, you get an image of the Gloucester football stadium. And that was their choice for image. So this is Gloucester football stadium at mean high water. No problem there. This is Gloucester football stadium with 6 feet of sea level rise or proxy storm surge. So let's get out of this and go over here. Okay. So this is what that website looks like when you start. And if you type in Rockport, Mass, it zooms right in. There's downtown. And on the left is, can you see the bottom of my screen now?
Mm-hmm.
Yep. So there's the slider for mean high water or up to 10 feet of sea level rise. And if we're talking about hurricanes, we can look at storm surge. So it would have to be a pretty ferocious storm, I think, to bring us that much storm surge. But even, I don't know, pick a number, 5 feet? 6 feet. 6 feet sounds good. So you can see, let's zoom in a little bit. We're losing a bit of bearskin neck here. And places there. Where it gets more interesting is on the south coast here. Loblolly Cove, the marsh behind it is in trouble. And the beaches on the south shore. There's Pebble Beach, Cape Hedge, and this is Long Beach. If you increase that, then Cape Hedge becomes an island, and the houses here are on an island, not much left of Long Beach. And Thatcher Road is underwater across the marsh here near Good Harbor Beach. So I thought this was an interesting website. You can make things really bad. And this is just, you know, hypothetical for now, but it does provide us with an interesting tool to sort of explore what could be. Right? Go back to downtown for a sec. Here we go. So there's 10 feet. Okay. Okay, a bit of good news is that the forecasts besides now having satellite and radar, the programs that are run to predict the track of the storms are getting much better. And when Laura was coming on shore, I think they called it to within a mile of the actual landfall location. So that is awesome. It really can help people who need to evacuate know that they need to evacuate. And we hope boost their confidence in those forecasts. This graph shows different time periods. So the red line is 24 hours, 48 hours, and so on, out to 120 hours. And time on the x-axis, the forecast error. So you can see that in 1970, the forecast error was quite large, not as large for 24 hours. One would hope that would be the case. But even now, 120 hours out, we're getting to the point where the forecasts are within a couple hundred miles of what actually becomes landfall location. So that's an improvement, to say the least. Okay, last shot here. This is from the NOAA webpage. They have a huge amount of information about hurricane preparedness, what to do and how to do it. It's not too different from preparing for blizzards and winter storms, so we're lucky in that respect. I think here in Rockport, we're fortunate, and in New England in general, in that our nastiest weather is something that can be predicted, and we know that it's coming, we can get ready, as opposed to, say, earthquakes in California or Japan or elsewhere, or tsunamis where you might have, a couple of hours warning. We've got days worth of warning for a storm like this, and so we can do what we need to do to be safe. And that is the end of my presentation. I do have a couple of slides with plenty of references and websites to take you out to the web so that you can learn more. And I thank you, and I'll entertain questions.
Sarah, a question about the two storms that caused so much damage at Long Beach, 1931 and 1958, I think. Were those
Okay.
associated with hurricanes?
31 and 58, I can't say, Tom, and I didn't live here then, and I wasn't even in Massachusetts then. But one thing I could take a look at is the NOAA page, if I can get back there. Let's see. So tell me the dates again.
I don't have the date in the year, but it was the year was 1931 for the first one.
31, okay. And okay, I'm not seeing, so what I'm looking at is hurricanes in history, and these are the storms that NOAA has summarized, and I'm not seeing either. In 1950 something you said.
58 was the other
58,
one.
no, I'm not seeing either of those.
Huh.
So they probably were not hurricanes.
Okay.
Yeah.
Well, I have a question with regard to both hurricanes and really big nor'easters, but specifically hurricanes. They can completely change subsequent weather patterns. Isn't that correct? Let's say you've had a long hot spell in the doldrums of August, and it might be a drought as well, like what we've been having. And then a hurricane comes by and completely alters all subsequent weather patterns. Is that just anecdotal, or is that a pattern that has been seen before?
That's a good question. And the first thing that comes to my mind is that you could have something like a cold front on the heels of a hurricane. So the hurricane, I'm imagining the hurricane exiting toward the North Atlantic, and behind that, west of that, is a cold front that would change the air mass. So you'd have cooler, drier air coming behind that cold front as the hurricane moves off the coast. I think too that hurricanes can bounce off of high pressure air masses, so that tracks can change given what, depending on what other weather systems are in place or moving into the area. You certainly got a sense of that looking at, if I can go back for a minute, that really scary picture with the smoke.
Oh, with the smoke, yeah. It was
Yeah.
definitely guiding the winds.
Yeah. So, you know, and then the other, let's see if I go from here. Up in the northwest here, the way that smoke is curling around, that could be a center of low pressure that's pulling the smoke into that spiraling low. Right here could be even a front right there, cold front, maybe. I'd have to go, you know, look at the map to take a look. But certainly, hurricanes are not in a total vacuum. They're going to interact with nearby weather systems. Yeah.
Any other questions?
Any other questions?
Karen?
What's the comparison between hurricanes and nor'easters?
So hurricanes are tropical storms. They form in the tropics. They need that warm weather component, and they do not have fronts. Their energy is derived from evaporation of water off the surface of the ocean and the cloud formation and so on that comes from that. Mid-latitude cyclones, nor'easters, form as a result of interaction between air masses that form frontal boundaries. So when those boundaries interact, you get a center of low pressure forming, and they have fronts. So if that that rings a bell with you, or is that?
Yep.
Yeah. So that's a big difference. Also, on average, mid-latitude cyclones are much larger than most hurricanes. So that's another difference. And so hurricanes have no fronts. It's all tropical air mass for them.
Sarah?
Yeah.
Hi, is a typhoon the same as a hurricane?
Yes, it is. And the typhoons, so the global term is cyclone, and that refers to any low pressure circulating weather system. Typhoons are in the Pacific, hurricanes are in the Atlantic. The word hurricane comes from native languages in the Caribbean, I believe. And it was sort of corrupted by the Spaniards and then, you know, other European languages. So it's the same kind of storm, it's just a different name attached to it. And storms in other basins of the world have their own sets of names that are already planned for them. There's a committee, I'd love to be on that committee, that selects names for the storms, and they go in a 6-year cycle. So unless a storm is retired, the way Larry Bird's number was retired from the Celtics, you know, then the names repeat every 6 years.
What year did they start using men's names as well?
Oh, I think back in the 50s, I want to say. That sounds about right. But they, yeah, no, in the 70s. Women's names in the 50s maybe, and men's names in the 70s, I would say. But I'd have to go double check that. Yeah. And before that, it was sort of like, you know, a date. There was the Labor Day hurricane. There was the Florida Keys hurricane of 1930 something. You know, they sort of attached a name and a kind of a date and kind of a location, but it wasn't terribly helpful, of course, as time went by.
Can I give you one tidbit that is good news about a hurricane?
Yeah, let's hear it.
I was speaking to a scientist who had worked in the Great Barrier Reef looking at coral bleaching. And he said that when we had the big, very large bleaching event that was worldwide, I think it was 2016, that the north part of the Great Barrier Reef was actually partially saved by a hurricane because it somehow, and it relates to what you were saying about upwelling of water, it was able to move the large blobs of, and he calls them blobs, large blobs of warm water out, whereas in the southern part of the Great Barrier Reef, that didn't happen. And so the corals bleached and died at a much higher rate.
Wow.
So the hurricane saved some of our coral reefs.
Wow. I've also seen, we were diving in Belize a few years ago, and they had a hurricane there at some point, and we saw coral reef rubble basically that had been caused by hurricane damage. So that was That was the flip side. It was pretty sad to
Right.
see. Yeah. It will recover in time, given the right
Yeah.
circumstances, but it's an
Yeah,
uphill battle these days for a lot of places.
sure
Well,
is.
the acidification recovery is dubious.
Yeah, exactly. Exactly right. And water temperature isn't going down very many places these
No.
days. Yeah.
Can I plug my book because it has 2 chapters on ocean acidification?
Yeah.
It's coming out December 23rd. So
And the name?
it's called Big Data in Small Slices. And it's mainly about the data that scientists use to predict what will be occurring by, say, the end of the century. So 2 of the chapters relate to that, and it's how it affects some of the animals, the sea animals, and of course the corals.
Wow.
So, and the data they collect and how they collect it.
I'm sorry, but I don't even know who is speaking right now. Can I know that?
Oh, it's Diane, your colleague and
Oh, Diane, hi. Yeah. I thought I recognized your voice, but I
Yeah.
wasn't positive. Thank you. Thanks for being here too. Awesome.
So Sarah, do you have any prognosis for the rest of this season?
Oh gosh, I wouldn't go there.
Are
I
you a
guess
scientist? You sound like a scientist.
Next
I am
few
a
years?
scientist, but I'm not a meteorologist. So
Okay.
yeah, I'm a geologist by training.
cool.
Yeah, I like rocks.
Mhm.
What was I going to say about this season? Bill, I think I'm sort of rooting for a couple more so that maybe we get past 2005 on the Greek alphabet. But, I'm not, I don't know. Time will tell. There is can you still see my screen?
Mm-hmm. Yes.
Okay, so if we go to, let's see. This is the tropical weather outlook for 5 days from now.
Mhm.
So there's Epsilon.
Hmm.
And there is a disturbance with a 30% chance of formation over the next 5 days. So that's something to watch.
Wow.
So, we'll see. Time will tell, right?
Mhm.
And right now, there's not much else going on. And I think Eastern Pacific is, not much going on there. Central Pacific is quieting down. But, there's one more website I want to show you guys. Here it is. I don't know if you've ever seen, this is the coolest website.
It is awesome.
Do you know this one?
Yeah.
Yeah, it's so awesome. So there's Epsilon out there cranking around. And if you go to the Western Pacific, this is also this is a tropical cyclone right now, cranking around. And it just within the last few days, I couldn't find a lot of information on it, but within the last few days, it crossed the Philippines and it's now headed for Vietnam. So they're watching that. This is another storm off the coast of India. It doesn't look severe enough to be a tropical storm right now anyway. And I haven't seen anything about that in the news. With this screen, it's really fun to spin things around so you can have a good time. But you can see, one of the things you can see is that the winds from Epsilon are screaming around and heading into the southeastern Atlantic coast for our country. Not much effect on us right now, but as this moves north, the forecast for us is to see a little more in the way of waves later this week. So that's kind of cool. Yeah, this is a really cool website.
I don't see Zeta yet.
No, not yet. Right, but it might form around here. It might form over here. So, and then it's always fun to look at the Antarctic. So amazing.
Yeah, they seem to have cyclonic systems that completely surround the continent.
Yeah, well, as the ocean does, and that's why. Yeah, and
What's
notice
what-
that these are all going clockwise. That's southern hemisphere Coriolis effect. So
What's the water temperature down there off Antarctica?
I have no idea.
Sounds cold to me.
Right now, it's probably chilly, but remember, they're going into summer. So,
Hmm.
yeah. You know, it's probably warmer than it used to be. That's a snide remark, but yeah.
And while you're
Anyway,
down there, you can note the West Antarctic ice shelf that threatens 25
Yeah.
feet of sea level rise.
right, exactly. Yeah. Any other questions?
Sarah, can you hear me? Sarah?
Yes, I can.
Okay, a couple of questions. Could you send out the links that you had on that page, or is it accessible somewhere?
On which page?
Oh, the one that had all the hyperlinks for everything that you were talking about, the
Oh
different
yeah,
links.
oh yeah, I'll do that.
Okay.
Bill is recording this presentation, and I can, Bill, I can send you the links to all those references. If
Okay.
that would be, I can do that, or Ian, I'll just send them to you.
Distribute the slides.
Okay. And
Yeah.
then I had a follow-up question.
Sure.
Globally, since temperatures are increasing on most television networks, in the south part of like the west coast of South America, where the El Nino La Nina oscillation takes place,
Right.
if we're looking at a gradual warming of the oceans, are we slowly trending towards more La Ninas and fewer El Ninos?
That's a really good question. This is another one of my favorite websites. This is the Jetstream School for Meteorology, online school for meteorology, which is part of
Yeah.
NOAA's.
Yeah, I subscribe to part of that. I get the report
Yeah.
on the transition.
That's a really
so.
good question. I'm not sure. And I think, you know, what also needs to be happening to push between La Nina and El Nino is a change in the strength of the trade winds.
Right.
So it's trade winds strengthening that brings that allows that colder water to rise to the surface for La Nina. It's trade wind weakening that pushes the warm, you know, lets the warm water slosh back towards South America, that brings that warm bit to the coast there. So
Okay. I guess
yeah.
slosh is a technical term.
Slosh is a technical term. Yeah.
Excellent.
Yeah. So there's the normal, you know, the neutral.
Yep.
And El Nino is on the top. So the sad thing about El Nino is that Australia sees droughts in that situation because the rain moves eastward and falls
Yeah,
on
and
the ocean where
Indonesia
nobody
too.
needs it. Yeah.
Yeah, they get
Right,
slammed.
exactly. And
Yeah.
this is what we're in now with the La Nina, where there's more upwelling and the rain is pushed over to the west. Cool.
Okay, thank you.
Yep, you're welcome.
So Julian had a recommendation, Sarah, for you to share your PDF. And
Okay.
people can get all the links from the PDF. In other words,
Right.
turn your PowerPoint into a PDF.
Yep, we'll do. Yep, I can do
Okay.
that.
And
So,
in posting the video, I could leave a comment,
okay,
which includes a link to the PDF.
right. And how can I, you know, I can put a PDF on my Google Drive, but then I need to know everybody's email. So is there a way to?
I
Sarah.
could just do that, or we could put it on the
Website.
Rockport
website.
Earth Day 2020 website.
Yeah, we could do that. Okay.
Yeah, Sarah, when I put that up, can you hear me? When
Yeah,
I put that up, I can put a little message that has little places for links.
oh, hi, Jerry. Yeah, okay.
And a whole section of just links if you want me to do that. I
Okay,
can
we
put
can do
it
that.
together. You can put your PDF up there and people
Okay.
can go through it and have it right there. It'd be very easy.
Okay, that sounds good. Sounds good. All right.
Very good. Very good conversations. I love this.
Yeah.
It's amazing. My husband, my oldest son is a meteorologist. I'm sure he would have had lots of comments and very much, you know, interactions with some of this kind of thing, because he was telling me about the El Nino, that, yeah, we're going to be getting more winter weather over here because of the
La
lack of
Nina,
weather
yeah.
west.
Right. Well, it's already snowing in the upper Midwest. They're having a
That's right,
crazy
right.
October. Yeah.
So,
Nuts. Yeah.
yeah.
Wow.
Did you happen to say the jet stream was slowing? I don't know if I caught that right.
Yeah, that's what I said. That's what I read. So that's what I said.
Wow.
And yeah, it's kind of eerie to me, but
Yeah.
yeah, and I don't know whether it's intermittent slowing, episodic slowing, permanent slowing, global slowing,
Yeah.
regional slowing. It's hard to know. So that deserves some more digging, I would say.
Yeah.
Yeah. Yeah. It's intriguing.
It'll take longer to get to England then.
Yeah, right. Exactly. And the jet stream does help to steer storms as well. So
Oh, it's weird. Yeah.
yeah, it's going to be.
Hmm.
It's a different world, and
I think the overall warming is reducing thermal gradients across
Mhm.
the globe.
Right, right. And then I also see a lot of print about the jet stream being sort of more sinusoidal than it has been on occasion. That's what gives us our polar vortex outbreaks in the winter, that sort of thing. When the jet stream is dipping way south, and one side of it's going to be really cold, the other side is going to be unusually warm. Yeah.
And then there's these atmospheric rivers I just started hearing about.
Yeah, like the Pineapple Express that brings rain to the West Coast. Yeah.
Oh,
Yeah.
weird.
Pretty wild.
Right.
Yeah.
It's a very complex system.
It is. Yes.
Yes.
Yeah. An experiment with an N of 1.
Yes, yes.
Yeah.
Well, Sarah, this was a great presentation.
Thank you, and
so
thanks
glad-
everybody for being here.
So glad you agreed to do this and be a major contributor to Rockport Earth Day 2020 events.
Yeah.
We'll probably have another event in November, another one in December. I guess we're supposed to be deciding on that tomorrow.
Yeah, I think so.
And in the meantime, I'll make sure to get your presentation on Doc Waller's Earth and Space Reports
Great.
YouTube channel.
Thank you so much. And if Tom is still there, thank you for the help with the audio bit.
It is Zoom.
Mr. Zoom.
The Zoom guru. Yeah.
And thanks to Mike for being our host.
Indeed. Thank you, Mike. Yeah.
With infinite time on the Zoom platform.
Yeah. So I understand. Great.
All right. Thank you all.
Okay. Thank you, guys.
Thanks so much. Thank you.
Yep. Hope you enjoyed it.
Yeah.
Thank you.